Hello everyone. In this video, I will explain about structural join in XML evaluation techniques. I hope you all are familiar with the XML identifiers. Within XML document or XML store, each node must be assigned a unique identifier or ID in short. Such identifiers for XML nodes plays the role of primary key, as in the case of traditional database system where each primary key will identify some object, which allows this node identifier allows to distinguish that node from all other nodes even if they have same label. Even if two nodes have same label, then the node identifier allows us to distinguish the node from all other nodes. These node identifiers are needed to indicate how nodes are related to one another in XML tree. This is important when your XML data is fragmented using horizontal or vertical partitioning and stored at multiple locations, and we need to reconnect children with their parents. So node identifiers should be such that just by looking at the node identifiers, we should be able to identify the relationship between the nodes. The relationship could be parent-child or ancestor-descendant. Now, how you can use these pre-post identifiers to find ancestors? First question is how these pre-post identifiers are assigned to the XML nodes. Perform pre-order and post-order traversing on the XML tree and attach these pre-order and post-order numbers to the nodes. In this way, you will get the pre-order value for the node and post-order value for the node, and this pre-order value and post-order value pair will serve as a pre-post identifier for that node. Now, how to decide for two nodes n1 and n2 whether n1 is ancestor of n2. Check for the two conditions. The first condition is n1.pre should be less than n2.pre, and second condition is n1.post should be greater than n2.post. Here n1.pre is the pre-order value for node n1, n2.pre is pre-order value for node n2, and n1.post is post-order value for node n1, and n2.post is post-order value for node n2. Now, if both these conditions are satisfied for the nodes, then n1 is ancestor of n2. Now consider this example here. Suppose node n1 have node identifier 1110, n2 have node identifier 129. The first part in the identifier indicates pre-order value, and the second part in the node identifier indicate post-order value. This one. Here the first value indicate pre-order value and second part indicate post-order value. Now here n1.pre is 11, n1.post is 10, n2.pre is 12, and n2.post is 9. Now check for the conditions. n1.pre less than n2.pre. n1.pre is this one, 11, and n2.pre is 12. 11 is less than 12. Yes, the condition is satisfied. First condition is satisfied. Now check for the second condition. n1.post greater than n2.post. n1.post is 10 and n2.post is 9. 10 is greater than 9. Yes, the condition is satisfied. Here both the conditions are satisfied. So n1 is ancestor of n2. n1 node is 1110 and n2 node is 129. Now consider the second example. This n1 node have node identifier 1315 and n2 have node identifier 1916. Here n1.pre is 13, n1.post is 15, n2.pre is 19, and n2.post is 16. Now check for the conditions. n1.pre less than n2.pre. n1.pre is this one 13 and n2.pre is 19. 13 is less than 19. Yes, the first condition is satisfied. Now check for the second condition. n1.post is n1.post greater than n2.post. n1.post is 15 and n2.post is 16. 15 is greater than 16. No, the second condition is not satisfied. So N1 13 15 node is not an ancestor of node N2 19 16. So this way you can check whether one node is ancestor of other node or no, not. Now the question is, what is structural join? Structural join is operator used to combine tuples from two inputs. If you have two inputs and you want to combine tuples from that two inputs, then the structural join can be used. Much like in the regular join in a relational database system, what does it do? The nature a regular join in relational database system, it combines tuples from two relations based on some criteria or condition. There is some equijoin conditions, and based on that conditions the tuples from the two tables are combined. Now in structural join there is structural condition instead of equijoin condition, hence its name is structural join. Now there are various forms of structural condition. One is a parent of condition and another is ancestor of condition. I will explain it. Consider P1 and P2 be some partial evaluation plans in XML database. Attribute X is in the output of P1, so it is denoted by P1.x, and attribute Y is in the output of P2, so it is denoted by P2.y. Both P1 and P2 contains structural IDs. Now this symbol denote the binary relationship is parent of. Means suppose if there is some relationship like this, X and Y are some attributes, then this structural condition specify that X should be parent of Y. Now this particular symbol denote the binary relationship is ancestor of. So consider this example. If the relationship is like this, X and Y are some attribute, then this condition indicates that X should be ancestor of Y. So these are the example of structural condition. So the structural join can be formally defined as this: the structural join of P1 and P2 on the condition that P1.x be an ancestor of P2.y. If you want to define structural join between P1 and P2 contain some tuples, then you can specify the structural condition, structural join using this formula: P1 join P2, but the condition is node X should be ancestor of node Y. Same way, if you want to define the parent-child relationship between the X and Y node, then you can specify this condition: P1 join P2, but the condition is X is parent of Y. So it will only join the two tuples when node X is the parent of Y. In this way you can define the structural join condition. Now there is an algorithm for performing the structural join, which is a stack based join algorithm that uses the stack. I will explain that in next video. That's it for now. Thank you.